All right, good morning, good afternoon, ladies and gentlemen. Welcome to this series of tutorials. Um, for the first part of this lesson, I forgot to add Mike's line. But Mike, you can just introduce yourself and where you're coming from, what you're studying. Yeah, so Mike is actually from Ethiopia, so you can just introduce yourself, Mike.
All right, it's a pleasure to be here. I'm a student from Ethiopia. I'm studying in Ethiopia Technical University, and I'm still doing freshman. Uh,
All right. Thank you very much, Mike. You can just read for us the question that is on top there. You can just read for us, then we proceed.
all right. Okay, the question goes: you throw a ball with a speed of 45 meter per second at an angle of at an angle of 40 degrees above the horizontal, directly toward one, as shown in figure below. The wall is 22 meters from the release. So, part A, how long does the ball take to reach the wall?
Just a minute. Just a minute. All right, all right, all right. Okay, I'm sure you can see my screen right now, right?
I can see it.
Okay, so you're saying the horizontal. Which one is the horizontal? Is it this one or this one?
Horizontal is this down one having 22 meters.
All right, all right. So you're saying the horizontal is associated with what?
It is associated with sine.
No, so the horizontal is associated with cos. So you say velocity in the x is equals to the given velocity, which is 25 cos
Then cos
the angle
theta,
theta, which
which is
is
40.
40. Okay, and when you calculate that, what are you getting? 45 cos 30. What is it giving you?
We are getting 19.15.
Are you sure? Start with, is it cos, it's cos, oh, it's cos 40, right? That is 19 point what? 19 point?
1.15.
All right. Yeah. So we also do the same for the y. We say Vy is equals to, we say the vertical is associated with which trig function?
The sine.
Yeah, so we'll say 25 sine 40, which is giving you
16.06.
15.06. Okay, this is meters per second.
16.
Sorry, 16?
It is 16.
All right. Okay, 16.06. Okay, so this is meters per second. This is also meters per second. So now after resolving our velocity into components, we can now calculate how long it takes the boat to reach the wall. So how long deals with time. So for us, the time that we are looking for is the time the ball moves from this point all the way to this point. So for us to find time, we can use again the horizontal distance here. Okay, so we have the horizontal distance and we also have the horizontal velocity. So in the horizontal, if we want, we can separate things in the horizontal. And remember what we said, time in the horizontal at a particular point is equals to time in the vertical. Okay, so yeah. So then here we just need to put horizontal details alone. Okay, horizontal details, we have velocity in the x, which is at 19.15 meters per second. We also have the displacement in the x, which is 22 meters. In the vertical, we only have the velocity in the vertical, Vy. Velocity in the vertical is 16.06 meters per second. Okay. Yeah, so that is what we have. Now to find time, we can use information in the horizontal there. So we can use the same formula that we used. Remember the formula that we used? So what is the formula that we use? X is equals to ut plus,
V initial
yeah,
half GT squared.
like that. Okay. Though, yeah. So we can use this formula. Basically. So our initial velocity will be this velocity that we have in the vertical. So our x is our distance which it has moved. Okay, so our x is the distance that it has moved. Our g is our acceleration due to gravity. Then time, it's the time it covers that displacement. Is that okay? Yeah, so you can just calculate for me, then we put the figures there. So our x will be 20, this will be 22. 22 will be equals to our initial will be 19.15 plus 1/2. Our acceleration is 9.8. Actually, here there is a t here that we forget, and here there's a t squared. So you can just quickly, yeah. So this will be 22. So this will actually be a quadratic equation, as you can see. So this will be 22 is equal to 1.15 t plus, we can simplify this. This will give us what is
4.9.
yeah, 4.9
4.9
t squared.
T squared.
So you have to solve this quadratic equation so very fast. Mike,
Yeah.
just something that that came to my mind. Just something that, yeah, just something that came to my mind. What we can do is this. Since we have, okay, we don't need to trouble ourselves with this. What we can do is this. Since we have velocity in the x, yeah. In fact, let me use that. So since we have, we know that what is the displacement equal to?
22.
No, displacement is equals to velocity times time, right?
Velocity times time. Yeah.
Yeah, so we can simply use this formula to find the time it reaches the wall there, so that we just minimize those that long calculation there. You get the idea, right?
Okay.
Yeah. So since we have,
I got the idea.
yeah, since we have displacement in the x and we have velocity in the x, we can simply find time.
Velocity.
Yeah. So time will be equals to displacement in the x divide by what? Divide by velocity in the x.
Velocity in x.
Yeah. So
22 out of 25.
22 divided by velocity in the x, that is what?
5.
No, it's this one. 19.25.
25.
Yeah,
19.
19.15.
4 seconds.
It's going to give us what?
1.14 seconds.
All right. That is way easier than the route that we wanted to take. You see that, right? Yeah. So that would be our time.
What is it?
Yeah. So this time is the time it takes to move from this point and to hit the wall there. So it's the same time it takes the, yeah. So basically that's the time that we have there. Okay, is it clear on that one, or maybe you have questions? Do you have any?
Clear?
All right. Okay, let me just erase this so that we can do the second one. So now we have the time from this point to that point. How far from the release point will the ball hit the wall? Okay, how far from the release point will the ball hit the wall? How do you think we can approach this one? How do you think we can approach this one? B?
So, yeah, they're asking for the height at which the ball hits the wall, no?
Yeah.
Okay, so I think we are going to use this formula where height represented by h equals to a half gt squared.
Half gt squared. So this one, we'll use the full one because we have the initial velocity, which is the velocity that is being projected with. So we have that. So we can just say height is equals to velocity in the y. And since going up from here, so we are taking the velocity from here going up. Okay. So since going up, we're going against gravity, we're going to use negative half, then gt squared. Are you getting that? Or even from starting here, going up to wherever it will hit the wall, we're using, we're going against gravity, so we use negative half right there. So our height, yeah. So our height will be equals to velocity in the y, which we already have, which is this one here. And here they should be times t. Okay. Yeah, height is equals to velocity in the y times t minus half gt squared. So here we have velocity in the y, which is 16.06 times t, the time we have, which is the same time, which is this one, 1.14 minus half. Okay, so minus half. G is 9.8. Then the time, which is 1.14 squared. So yeah, so when you simplify this, what are you getting?
18,
That is
18.30, 18.30 minus 6.36.
18.30 minus, okay, what, and when you subtract, what are you getting?
18.06. We're going to get 11.9.
11.9. All right, 11.9 meters. So that will be the height at which it will hit the wall. So that will be the height at which it hits the wall. Okay. All right. So that will be the height at which it hits the wall. Let me just clear out what is down here. So now you can read for us question C.
Okay. Part C. What are the horizontal and vertical components of its velocity as it hits the wall?
All right. So as it hits the wall, what you should know is that velocity in the x component does not change. So velocity in the x component will be the same. We just need to find velocity in the y component. So velocity in x component,
Constant.
yeah, which is equals to what? What would be the velocity in the x component?
19 point, 19.1.
Yeah, 19.15. So that's the velocity in the x. So now we need to find velocity in the y component. Okay, and basically we can simply use the formula acceleration is equals to v final minus v initial over time. Making v final subject of the formula, we're going to have v final is equal to what? It will be what? V final will be equals to what? V initial minus at, like that, right? So we are looking for the final velocity. The initial velocity is the velocity in the y. You get that, right? That's the initial velocity because the boy is that, yeah. So the boy is starting here going up like that. So it is the same thing. It is starting here going up. It is starting here going up, starting here going up. So we have our initial velocity. So v final will be equals to our initial velocity will be the velocity in the y. And what was the velocity in the y?
16.06.
Yeah, 16.06 minus acceleration. It will be acceleration due to gravity. So what what will be the acceleration?
Is 9.8.
Yeah, 9.8. Then times the time, which is 1.14. So when you simplify that, what are you getting?
Getting 4.88.
4.88 meters per second. So that will be your velocity in the y. So we can simply call this velocity y. Instead of v final, we can just say velocity in the y. So we can say velocity y, velocity y. So velocity in the x component will be the same, and the velocity in the y will be that when it hits the wall. Then we can do the last question of this one, which is part D. When it hits the wall, has it passed its highest point? So we need to know, we know first of all the height at which it hits the wall. Okay, let me just erase everything. What height does it hit the wall?
11.9 meters.
That is 11.9, right? So height, we say height it hits the wall.
11.9.
That was 11.9. Okay, so now we need to find the maximum height. So the maximum height, when the ball is moving up like that, it reaches a point where the final velocity is equal to 0. Okay, and basically the initial the initial velocity is the velocity in the y. So the velocity in the y was what, 16.06, was it?
16.06.
Yeah. So when it starts from the ground here, it starts with an initial velocity which we've been given, and when it reaches that height, the final velocity is 0. Then we can use the formula v squared is equal to u squared plus 2as to find the displacement, basically. Okay, so again, since we're going up, acceleration will be equals to negative 9.8, since we're going up like that. Yeah, so v final is 0 and v initial is the velocity in the y, which is 16. Yeah, so basically,
16.06.
yeah, so we just place in the values there. So our v squared, v final is 0 squared, because to the initial velocity is 16.06. We square that plus 2. Acceleration is negative 9.8 times the displacement x. So when we simplify this, we can simply say this comes this side. So what is so this would be 0 equal to, what is this when simplified?
257.9.
257.9, like that. Is it like that?
Yeah, like that.
Okay, then for the other one,
And minus 19.6x.
19.6x. Okay, then we simply just transpose this part so that push. Okay, so we simply transpose this part. We have negative
257.
negative 257.9 equal to negative 19.6x Divide by negative 19.6. Divide by negative 19.6. We cancel that. Then we say x will be equal to what?
13.15.
13.15. Okay. So now let's look at this. So the height at which it hits the wall is 11 meters.
11.9 meters.
And the maximum height is 13.15 meters.
0.15.
Did the ball pass its maximum height when it hit the wall?
No, it didn't.
Very good. Yeah. So it didn't. So you make a conclusion to say since h is greater than x, I mean since x the other way around, right? Since x is greater than h, where x is the maximum height and h is the point it hit the wall, the ball did not pass. The ball did not pass the maximum height. So you just make that conclusion there. Do you have any questions that you would like me to answer, or do you have any questions on the lessons?
I think that will be all for today. I don't have any questions.
All right, thank you very much. Have a great evening.
Thank you.